So you did direct variation. You might not have done it in this kind of with this presentation though. So you might have done it just by setting up proportions. That a basic straightforward proportion is direct variation when things vary directly with each other. We're going to do it via this other method, which is sort of pointing out the linear relationship between direct variation, where k is really just takes the place of your slope. Okay, so y equals kx, and k stands for your slope. In order for things to be directly proportional to each other, there has to be a y-intercept of 0. So you don't see the plus b here for y equals mx plus b. You just see y equals mx. Okay. For inverse variation, so inverse variation is kind of a rational. It is a rational relationship between two variables, and the format that we'll use for that is y equals k over x. And joint variation is when there's kind of multiple variables varying with each other. Rather than just two variables, you've usually got three. In any case, we're going to memorize that formula for direct variation, that formula for inverse, and that formula for joint. And k is always the constant of variation. So if you ever see the constant of variation is 7, that means k is 7. Okay, so example 1, the number of gallons of water used when taking a shower varies directly. So it will always use the language verbatim. Varies directly, varies inversely, varies jointly. So varies directly as the time in minutes. So if we look at going back to this generic format, we would say that y varies directly with x. So I'm going to write that underneath. Y varies directly with x. So the way that it's phrased is pretty critical. So water varies directly as time. So water is like your y coordinate, so W equals K times T. And then they will, once you have that, they'll always give you one standing circumstance that's going to allow you to find K, the constant of variation for that problem. And this one, it's saying now a shower lasting 5 minutes, so T is 5, uses 30 gallons of water, so W is 30, and this is going to allow us to find K. So 30 equals K times 5, and then K obviously equals 6. So that's your constant of variation for this entire problem. Now that we know K, we can answer their question. How much water is used? So we're back to not knowing how much water is used in a shower that lasts 11 minutes. So K is 6 times T is 11 minutes, and we get 66 gallons. Now this question you would have been able to solve anyway with what your Algebra 1 proportion skills were. So when things vary directly, 5 minutes takes 30 gallons of water, so 11 minutes is going to take X gallons of water. Okay, so you get 5X equals 30 times 11 is 330. Divide both sides by 5. You would have gotten 66 as well. Okay, but proportions only work really well with direct variation. Okay, so they don't work well with inverse variation or joint variation. There is a way to do it, but it's much more confusing. So I'm just kind of going to change the way we used to do things and do everything consistently with their own particular format. Does this make sense? Questions on that? Okay. Here's a varying directly. The distance required to stop a car varies directly as the square of the speed. So not just another variable s, but the square of the speed. So the distance, d, equals k times, and since it's varying directly, the square of the speed will be s squared. So pay attention to language like that. It's not always just going to be variable varying with variable. It could be the variable squared or the square root of the variable. So be on the lookout for language like that. And then if 200 feet are required to stop a car, so your distance is 200, a car that's traveling 60 miles per hour, so 60 is your speed, we're going to use that known information to solve for k. 60 squared is 3,600. So I'm going to divide both sides by 3,600. So k equals, your zeros will cancel. 2 over 36 is 1 over 18. So how many feet are required? So what is our distance required to stop a car that's traveling 100 miles per hour? So k is 1 over 18. We've now established that. And the speed that we're looking for the distance to stop is 100. What's 100 squared? 4 zeros, 10,000, good. And then 10,000 divided by 18. I'm just going to reduce by 2. 5,000 over 9. Now, unfortunately, quick long division. How many times is 9 going to 50? 5. 45, do your subtraction. You got a 5, bring down a 50. 9 goes into 50 5 times. 5 times 9 is 45. Subtract, bring down your 0. Goes into 55. What's going to keep happening here? Right, 5 repeating. But now that I've finished my 5,000, I put my decimal and then 5 repeating. So it takes 555.5 repeating. Does anyone know what 0.5 repeating is as a fraction?
5 over 9.
Good. Do you guys know that rule? Like 0.4 repeating is 4 ninths. 0.3 repeating, which you'll know is 3 ninths, 1/3. 0.2 repeating is 2 ninths. Did you know that? No, you do. Anytime you have the same number repeating, it's that many ninths. I wonder if that works. Just curious. By the way, I think I just learned that like 5 years ago. I think I just like relearned it when I was tutoring a kid in like 6th grade math, and they were focusing on that, and I was like, oh, I didn't remember that. So now I do. But I wonder if that would work for like 23 ninths. I think that would be 0.23232323, or no? Is it only for single huh? I know we're going to. Oh, yeah. Well, what do you get when you do 23 ninths? So if I make it a mixed number, I get.
That's 2.5.
Oh yeah, I'd have to make it a mixed number. 2 and 5 ninths, and then it's 2.5 repeating. Yeah, the pattern's still there. I was just curious. Anyway, that's got nothing to do with what we're doing today. I was just curious. All right. Example 3, we get into an inverse variation. So, first of all, going back with direct variation, the variables typically move together. So, like for the water used in a shower and the time, obviously if the time in the shower increases, the water in the shower that you use increases. If the time in your shower decreases, the water that you use decreases. So they kind of move together. Same thing with the distance a car stops based on its speed. If a car is going slow, the distance to stop is faster, right? It's a shorter distance. Slower speed, shorter distance to stop. If you increase the speed of a car, then the amount of distance it takes to stop is also going to increase. Okay? Inverse variation kind of is the opposite of that, right? So in this one, the length of a violin string, and I guess I would talk to the musical people in the bunch, varies inversely as the frequency of its vibration. So the length of the string varies inversely as the frequency of its vibrations. So if you kind of have a short string and you, like on a guitar, and you pluck it, what's the frequency? Higher or lower than a longer string? Higher. So if you pluck a shorter string, it's got a higher frequency. Then when the length increases, when you pluck it, it's got a lesser frequency. So as your length goes up, the frequency goes down. So these variables are working inversely to each other. They're not working in the same direction. As one increases, the other decreases. At any rate, it's the length of the violin string, so let's call it L. Varies inversely, so that's the K over formula, inversely as the frequency of the vibration, so I'll use F. So again, you're always given a known circumstance that a violin string 9 inches long has a frequency of 650. Solve for K, multiply by 650 on both sides. You may find on this homework that you need your calculator, so 9 times 0, but I'm going to do this one without 5850. At least that part, but now I'm nervous with 5850. So then what is the frequency of a 10-inch string? So new circumstance, the length is 10. I now know K is 5850 over, and I'm looking for the frequency. Think logically first. We had a 9-inch string. What happened to the length? Did it increase or decrease? Increase. So we expect the frequency to decrease. So we should expect it to be something less than 650, and then we'll just do 10F equals 5850. Divide both sides by 10, F equals 585. So it did decrease. Good? All right. Okay, exercise 4. Oh, geez. Zach, will you read it for us? Okay. So, more variables floating around here. The number of minutes needed to solve an exercise set of problems varies directly as the number of problems. So that makes sense. The more problems, the more time it's going to take. But inversely as the number of people working on each problem. So if you've got more people working on the problems, then it's going to take less time, right? Because you've got, hopefully more people means you're going to get the answer quicker. So hopefully that makes sense. So this is an example of joint variation which kind of combines variations. So the number of minutes, we'll call that M. Thank you. To solve an exercise set of variation problems varies directly. So that's a K times the number of problems. So I'll say P. So there's the minutes varying directly with the number of problems. But inversely, so that would be K over something. Inversely as the number of people. Uh-oh. Number of minutes, you know. We'll do people. Persons. Number of questions. I like it. We'll have that be Q. Inversely is the number of people. P is people. Perfect. That's a small problem. And then just plug in the numbers and find your K. So the given situation that we know is that it takes 4 people. So that's our denominator. 32 minutes to solve 16 questions. So that's going to be 32 equals 4K. Divide both sides by 4, and our constant of variation is 8. And then we're going to go solve the question. How many minutes? So M equals. Our K is 8. Our new number of questions is 24. Our new number of people is 8. So your number of minutes is 24. Pretty easy stuff, right? Okay. So that is a version of joint variation, but it's kind of a mixture because with one of the variables it's direct and one of it with the other variable it's inverse. If they ever just say on exercise 5 that something varies jointly as 2 other variables, that's this one where you just assume it's direct with both of them. Okay? So the volume, V, varies jointly as its height, H, and the square of its radius. What does the square of a radius look like? R squared. Good. So go ahead and do the rest of that on your own. No calculators on this, by the way. Raise your hand if you're done. Raise your hand if you're stuck. Okay. Raise your hand if you just need more time. Okay. Take another minute. If you want to move ahead to number 6, feel free. Okay, Kendall, what did you get for exercise 5? Oh, okay. Sorry. You tell me when you're ready, and then everybody else, if you're past it, go on to exercise 6. I haven't done 6 yet, but just a heads up, I'm seeing a decimal, so I might find a calculator necessary. Yeah? What'd you get? 96 pi. Did anyone get anything different? Yes? What'd you get? Oh, what's that? 288 over 3. Okay. So actually, I want to talk about that. 96 pi is the correct answer. And when I did it the first time, I got 144 times 2, 288 over 3. You're going to get to a point in calc with me this year, and then again next year, where you're going to be doing a lot of this sort of thing, and we're going to need to find shortcuts for not having to go through long division. To be able to do this simplifying without a calculator. And the key, does anyone know how we could get this 96 without getting it into 288 divided by 3? Taylor? So 144 divided by 3, but that's still a little much, right? That still's not just something that people know. Okay? So you're going to kind of get used to almost like breaking the 12 down into 12 times 12, and that way your 12 thirds reduces to 4, and then it's 4 times 12 is 48 times 2 is 96. Do you see that? So kind of before multiplying these numbers to make them a big number having to divide by 3, find a factor of 3 somewhere in there and reduce it. Now you can't reduce this 12 with the 3, right? And make it 4 squared, because that would be doing division before you do an exponent, and that would, you'd actually be dividing out 3 twice, which you should not be doing. So just be careful of that. But that's why I split it up so you could see that just one of the 12s reduces down to a 4. And then you can do 8 times 12 is 96, or you can do 48 times 2 is 96, whichever way you can do that. But getting used to seeing little shortcuts like that to avoid long division. And number 6, raise your hand if you're done with it already. Liz, what'd you get? Anybody get any different? Okay, I'm just going to go through this really quickly. The distance, s, that a body falls from rest varies directly as the square of the time. So s equals k times t squared. If skydivers fall 64 feet in 2 seconds, divide both sides by 4, k equals 16. Am I doing that right? How far will they fall in 4.5 seconds? So s equals 16 times 4.5 squared, and I'm going to say, yeah, calculator for 4.5 squared. Times 16, you get 324. Did you use a calculator, Liz? Nice job, and she still got it. But decimals that don't work out nicely is sort of where I draw the line. Any questions? Pay no attention to that at the bottom, the Chapter 2 test, Monday 11/2. It's Monday 10:30. Right? Is that Monday the 30th? So your homework is right there. I'll put it up so you can have 10 minutes to start the homework. But your review sheet for Chapter 2 is also, it's been online all chapter long. In fact, Chapter 3 is up. So what I'm trying to do for you is put the review sheet up with practice multiple choice questions right at the start of every chapter, so you can always, on a nightly basis, kind of look for questions that are doable. You could use it as like a pre-test sort of thing to see what you already know and what you don't, and then just have a heads up for what's coming in that chapter, and then answer those questions as you go through the chapter. Because doing it all the night before is not really practical sometimes. I put a boatload of questions on there. Jalen, do you know how many questions are on this review packet? 88. So I just put any and every question I can find. Yeah. So I just do that. You don't ever have to do all 88, but maybe go through and look at ones that you think might give you trouble. Right. And I just put every version, so you'd see a question and then 5 in a row, or that same question with just different numbers. So kind of use your smarts and time management to figure out what's really necessary and what's not for you. All right. So tomorrow when we come in, we'll go over homework, and then any questions that you have on the review sheet, if you were able to look at it, we'll do. Other than that, I'll just have you work on it. But you study. Yeah. And tomorrow I'm going to give you back your Chapter 2 quizzes that you'll have for over the weekend to kind of brush up on anything that was, they were pretty good overall. I think I already put the grades in the grade portal. Did I? I think I did. So let me pull up page 364 so you can get started. 11 through 39. So you can get through 11 through 19.